So, thank you for joining in this meeting. So, I am Mathesh N, AI and Robotics faculty in Forsche Technology Solutions. So today's topic is getting started with ROS. So, ROS stands for Robot Operating System. Uh, Robot operating system is not an actual operating system. It's like a middleware. It's a platform designed to support robot software development. It has a collection of frameworks that simplify the building of robotics applications. ROS enables hardware abstraction and manages low-level device operations seamlessly. So this makes ROS as an operating system, but it's not an it's not like an official operating system like Windows, Ubuntu, Linux, and Mac OS. It's just a framework or a middleware that helps to develop the robotics applications, especially in the development of software. And it has a lot of frameworks, tools, libraries, and packages. So, history of ROS. The project ROS began in 2006 at Stanford. It was developed by some students in in Stanford as their project. So today, the Open Source Robotics Foundation (OSRF) has been maintaining the ROS and developing it since 2013. Today, it was used by many robots and universities, companies, and it becoming the standard for robotics programming. Okay, so this is the short history of ROS. And why ROS? So, as I said earlier, ROS minimizes the time by helping us to develop the software faster. So it eliminates reinventing wheel every time. Okay, some robotic application needs to be developed again and again. So it uses almost same software. So what we have to do is we have to develop that code again and again. Instead of doing that, we can use ROS and just eliminate that process of doing again. So that's what ROS is doing. It has pre-built tool libraries and other frameworks, so we can directly use them and make our robotic application much faster. So that's what ROS is meant for. Yeah. And the problem before inventing ROS. Okay. As I said, robotic application needs to be developed from scratch. Okay. Some robotics application have same set of software. So instead of doing the same set of softwares again and again, we can focus on research instead of writing the same code again. So ROS will take the part of developing code by the existing frameworks which has been developed by other developers across the internet, and we can focus on research part mostly. And I want to say one more example for that, which is ROS. Before ROS, development of robotics took years. Like most of you have seen a Sophia robot, which is a popular robot across the internet in during 2016 and 2017 period of times. So that robot took almost 9 years to develop it completely. And one more example is Honda's Asimo robot. It's a humanoid robot. It took almost 20 years to develop it completely. So ROS comes into action and eliminates those times of developing the software part and mu- and enable us to focus on spending more time in research that will create new innovation in robotics. So why ROS? And who uses ROS? ROS has been used across many industries like Think Robotics. It's a famous Rethink Robotics is a famous robotics company. It's using ROS, and most of the companies are using ROS for their robotics development. And even if they are not using in the final product, they are using it for prototype. And and companies like Amazon and especially NASA is using in their projects like Project Viper, and they are also planning to use ROS in their future products projects. Okay, so now let's move on to the technical terms of ROS. ROS is consist of some core concepts like nodes, topics and messages, services, actions, and most importantly, packages. So what is a node? So node is a small program. A robotics application has many number of nodes, and a node can be anything like a node, like we can create a node for a sensor, we can create a node for a motor, and we can create a node that handles the properties of a camera. Okay, so nodes are the parts. If a robot has many sensors, many cameras, many actuators, each of them is considered as node in software terms. So each node will communicate with other nodes in order to pass the information that do a certain thing, certain process in a robotics body. Okay, each program runs on its own and managed by separately. And especially ROS nodes are created in two softwares. Like one is RCL Pi and RCL CPP. RCL Pi is used for Python version and RCL CPP is used for C++ version. Okay. Topics and messages. As I have said about node, you may have got some idea about node. So how, yeah, as I said, node will communicate with other nodes. So how it will communicate? That's where topics and messages comes into play. A node will pass a message to a topic, and another node will take that message and use it for a particular process. So how? Topic act like a channel. It gets the message from a node and sends it to another node. Topic is basically a channel which nodes can put the message into it and can take the message from it. A publisher node will publish a message to the topic. Okay, and especially those messages can be of different types. In ROS, there are many different type of messages for each application. Like for camera, we have different type of messages. For activating a motor, we have different type of messages. Okay. The node which passes a message at a certain type, and a node which is receiving a message can be the same type. Okay. Unless otherwise they cannot access those messages. Like I said, topics will receive the message and share that message. Okay. Okay. This is the structure how the messages has been transferred between nodes using topic. Okay. You can see a subscriber node is receiving the message while a publisher node is publishing and message. And one more thing, these message systems cannot be an one-to-one communication. Okay, there could be multiple subscriber nodes and multiple publisher node can publish to a topic and can be subscribed from that topic. Okay, so a node, yeah, communication might not be one-on-one communication here in nodes particularly. There could be many number of nodes can receive the same message, and there could be a single node that can receive multiple messages from different publisher nodes. Okay. Finally, we are moving into services. A services is a request response model. It's if you know about nodes, it is easy to understand. Okay. As I said, topic is the a medium of transferring the message. Here, it's a response model. What happens here is a server node will send a response to the client node only when the client node requests a message. Okay, the message will be sent only the request is happened. But before in node concept, node topic concept, the message is always has been sent to the topic and constantly received by a subscriber node. Okay, but here the message is only sent when the request is occurred. And this is also should not be an one-on-one communication. This should also have many number of client nodes, but only one thing is it should only have a one server node. Okay, but there could be many client nodes. And the next concept is action. It is similar to services concept, but the only major difference is it is used in real hardware. What I'm saying is, so if we are into a navigation task and you have to handle real hardware, you can use actions instead of request response model. Sorry, that services model. This is also a request response model, but here you can cancel the task in middle of the task. If you feel the system is malfunctioning, you can cancel the task at the middle of the task is happening. And one more thing, you can get the feedback constantly from the server. Okay. These are some two additional things happening in actions, and this is used for long-term operations. Okay, it will happen until you cancel that task. Okay, and it will also send the feedback until you get the task cancelled. So this is the architecture of this model. You can see it's also a request response model, but additionally it's sending a feedback, and also we can cancel it during the process. And finally, packages. We have seen about the communication models, but uh, to make it more organized, ROS uses package models. Okay, a package can consist of multiple nodes and multiple other type of services, actions, all those things. All of them are packaged in an organized manner, which is called package. Okay, we can use it for our other projects, and we can use an existing package, which is we will use for our project also. So this is the structure of packages. This is the main workspace. Inside it, we can see four more folders. And mainly, all our code which we are developing during the robotics application are stored in the SRC folder, which stands for source. Inside it, you can see build, install, log, and other programs which you have been developed during the development of robot. Here you can see the SRC part is only consisting the coding part of a robot. So what we can do with this package model, we can use it for later users, and we can publish it in internet, and anyone can use it for their robotics application. As I said, for why ROI is meant for is to reduce the time of developing. So if you are making your package available to internet, someone can use that and develop their robotic application much faster. And like that, you can use some others packages from internet and use it in your robotics application and make your robotic applications much faster. And finally, uh, for the communication, I just want to say some examples, a talker and listener part. So I can show the demonstration, but it is not happening at the with this setup. So I just show what is a talker and listener in ROS. These are some demonstration used in ROS to learn about ROS concepts. You can see, as I said, earlier, how a node will communicate. It, the publisher node will send that data, the subscriber node will receive that data. So here, what I want to say is, a talker node will send a message called "Hello World." The listener node will receive that message. So this is the output of a listener node, which printing I hear. What it means is, a talker node is sending "Hello World," and listener node is replying to that by the message I heard. This is how the communication happens in ROS. And one more important thing in ROS is turtle sim, which is especially used to practice the concepts in ROS. The turtle sim is the starting point of ROS, which who wants to get into ROS. If you are new to ROS, just try the turtle sim first to get familiar with some concepts, and you will get some ideas about ROS. So basically, turtle sim is a simulation, a 2D simulation, and you can control it, 2D simulation, uh, in which a turtle is inside that simulation. You can control it through your keyboard. So you can see how communication will happen inside ROS. In upcoming sessions, we can focus on more technical parts, and we will install the recorder software for our ROS development. And also, we will see more about turtle sim and Docker listener part practically. So now, I just want to conclude the session. If you are having any questions, you just leave it in the comments. So, and I want to thank again those who are joined in the meeting. So stay with us for upcoming sessions. Thank you.